Welcome, everyone, to our comprehensive tutorial on understanding certificates and certificate authorities. In today's digital world, security is paramount, and certificates play a crucial role in establishing trust. This tutorial will guide you through the intricate web of digital certificates and certificate authorities. So, what exactly is a digital certificate? A digital certificate is an electronic document that uses a digital signature to bind a public key with an identity, a person, organization, or device. When you connect to a secure website, your browser checks its certificate. Next, a fundamental concept we need to cover is Public Key Infrastructure, or PKI. PKI is a framework that helps manage digital certificates and public key encryption. It allows users to securely exchange data over networks and ensures the authenticity of public keys. Let's look at the anatomy of a digital certificate. A typical digital certificate includes the following components: the version, serial number, algorithm information, issuer name, validity period, subject name, subject's public key, issuer's unique identifier, and a digital signature. Now, let's review a code example to see how a digital certificate is structured. Below, we create a self-signed certificate using Java's java.security package. First, ensure you have the necessary libraries imported. In this example, we are generating a key pair and will soon call a method to create a self-signed certificate. The key pair generator generates a public-private key pair using RSA algorithm. Now, let's discuss the role of certificate authorities, often abbreviated as CAs. A certificate authority is a trusted entity that issues digital certificates. CAs validate the identity of organizations and individuals before issuing a certificate to ensure they are indeed who they claim to be. CAs perform rigorous validation processes to issue certificates. The methods of validation can include domain validation, DV, organization validation, OV, and extended validation, EV. Let's briefly look at each of these methods. Domain validation is the most basic form of validation. The CA verifies that the applicant controls the domain for which they are requesting a certificate. This can be done through email verification or DNS record validation. Organization validation involves a deeper level of validation where the CA verifies the legitimacy of the organization behind a request. This process includes checks for business registration and identity assurance. Extended validation requires thorough examination and provides an extremely high level of trust. It includes verifying the legal, physical, and operational existence of the entity. Websites with EV certificates are displayed with a green address bar, indicating a higher assurance level to users. Now that we've covered what CAs do, let's look at how these certificates work in practice. When you visit a website, your browser establishes a connection to the server. If the server presents a certificate, the browser will check the issuer's validity and ensure the domain matches the certificate. If the certificate is from a trusted CA and has not expired or been revoked, the connection is considered secure. This process of checking is called certificate validation. Let's implement a simple example of making an HTTPS connection using Java. We'll use the HTTPS URL connection class to make a secure connection to a website. Update your project with these libraries. In this code snippet, we establish a connection to https://www.example.com. The HTTPS URL connection class handles the details of the SSL/TLS handshake, where the client and server establish a secure connection based on the certificates presented. Next, let's focus on certificate revocation. Revocation is essential as it allows CAs to invalidate certificates before the expiration date. This may happen due to compromised keys or user request. Two common methods of revocation are CRL, Certificate Revocation List, and OCSP, Online Certificate Status Protocol. Certificate revocation lists are lists published by CAs that include serial numbers of revoked certificates. Browsers check this list periodically to determine the validity of the certificates they encounter. Let's see a code snippet for how we might check a certificate against its CRL. On the other hand, OCSP is a real-time protocol that allows browsers to query the CA for the status of a certificate. This enables quick validation without having to download the entire revocation list each time. Java security libraries can automatically handle OCSP requests as part of the SSL/TLS handshake. As an exercise, you could try implementing your own certificate verification process using OCSP. Integrate with a CA that supports OCSP requests and utilize the sockets for verification. Now, let's talk about the different types of certificates. There are SSL certificates, code signing certificates, and client certificates. SSL certificates are used primarily for securing web traffic, while code signing is crucial for verifying the origin and integrity of software applications. Client certificates provide a way for users to prove their identity to a server. They are particularly useful in situations requiring high security, such as online banking systems. Let's take a brief look at how you might implement client certificate authentication. This snippet demonstrates how to load a client certificate from a PKCS12 key store and set up SSL context for a connection. As we move towards the conclusion of our tutorial, let's recap what we've learned. We started by understanding digital certificates, the components that make up a certificate, and the critical role of certificate authorities. We delved into the validation process done by CAs, the different validation methods, and the essential processes involved in establishing secure connections through HTTPS. We also explored certificate revocation and how OCSP, alongside CRLs, play a role in maintaining trust in the digital landscape. Finally, we examined the practical applications of client certificates and how they enhance security. I encourage you to further explore these concepts, implement them in your own applications, and foster a deeper understanding of digital security. As a takeaway, remember that digital certificates and CAs are vital components in maintaining the integrity and security of our online interactions. Thank you for watching this tutorial on understanding certificates and certificate authorities. If you found this video helpful, please give it a thumbs up and subscribe for more in-depth programming tutorials. Hit the comments below with any questions or topics you'd like us to cover next. Until next time, keep coding securely.